वेलकम माय डियर स्टूडेंट। आप लोग तो थर्मोडायनामिक्स का फर्स्ट लॉ सेकंड लॉ पढ़ा ही होगा, लेकिन आज मैं कुछ ऐसे क्वेश्चन आंसर का डिस्कशन करूंगा जो आप लोग पढ़ा है और नहीं है वो दोनों लोग के लिए ही बहुत ही फायदेमंद साबित होगा। इट इज़ वेरी यूजफुल फॉर द स्टूडेंट्स। तो आज मेरा जो टॉपिक है वो थर्मोडायनामिक्स के ऊपर है, ऑन द बेस्ड ऑन फर्स्ट लॉ एंड सेकंड लॉ ऑफ थर्मोडायनामिक्स। और सिर्फ 5 ऐसे क्वेश्चन हम डिस्कस करेंगे जो रेयर टाइप क्वेश्चन है बट इम्पॉर्टेंट है। अगर आपको क्वेश्चन का उत्तर मालूम है तो आप कोशिश कीजिए, और अगर नहीं मालूम है तो मेरे वीडियो को देखिए अगले दिन, और नेक्स्ट राउंड में मैं और भी ज़्यादा अच्छे अच्छे वीडियो लाऊंगा टॉपिक के ऊपर, टॉपिक डिस्कशन भी करूँगा। तो लेट्स स्टार्ट। फर्स्ट क्वेश्चन इज व्हाई हीट और मैकेनिकल एनर्जी, व्हाई मैकेनिकल एनर्जी is transferred into heat totally but heat cannot totally transferred into मैकेनिकल एनर्जी और वर्क। सो मेरा पहला जो सवाल है ये है कि व्हाई मैकेनिकल एनर्जी इज ट्रांसफर इनटू हीट टोटली बट हीट कैन नॉट टोटली ट्रांसफर इनटू वर्क। सो अगर आपको मालूम है इसका आंसर तो कमेंट बॉक्स में लिखिए और बोलिए अपने आप ही, और अगर नहीं मालूम है तो प्लीज़ मेरे चैनल को देखिए। Because when some heat is, the answer is when some heat is transferred, when some mechanical energy is transferred, when some mechanical energy, we abbreviate it as ME, is transferred into system, it increases or it's stored as a kinetic energy. The system absorbs it as a form of kinetic energy. Then the kinetic energy is transferred into heat by any procedure. But when the reverse phenomena occur, that is when heat is supplied, the total heat cannot be get into mechanical energy or work because of first law of thermodynamics. We know that first law of thermodynamics is total heat, that is dq, is given to a system is dissipated or used in two ways. One is to increase its internal energy and other doing some external work. So when heat is supplied to a system, a part of it is doing external work, but some part of it is retained as internal energy or increase its internal energy. So we cannot totally transfer the heat into work. समझ में आया ना? ये क्वेश्चन बहुत इंपॉर्टेंट है थर्मोडायनामिक्स के लिए और आउटसाइड द बोर्ड एग्जाम दिस इज ऑल्सो वेरी इंपॉर्टेंट। नेक्स्ट मेरा जो दूसरा सवाल है वो है डज द मास ऑफ ए बॉडी चेंज व्हेन इट इज हीटेड? डज द मास ऑफ ए बॉडी चेंज when heated। जब किसी बॉडी को हीट देना पड़ता है आउटसाइड से, तो क्या उसका जो मास है, उसका जो भर है, उसमें क्या कोई चेंज आता है और नहीं, और ये अनचेंज रहता है। क्या होगा इसका आंसर? Obviously the answer is yes, it's mass change, because when the body is heated, when the body is heated from outside, that is energy absorb it, energy absorb the system, or when the body is cooled, then energy released from the system. Now according to Einstein, E equal to mc square, if there is change in energy, there is change in mass also occur. So when a thermodynamic system is heated or cooled, then energy absorbed or either energy released, that is the change in energy occurred. There is change in energy occurred. So there is change in mass also occurred, but as c is the velocity of light, it has magnitude is 3 into 10 to the power 8 meter per second. So this is a large value compared to mass. So the change in mass is infinitesimal small. So mass change occur, but it is very small. I hope you understand the answer. Next we go to with the third example. The third question is two isothermal curve intersect each other or not, and obviously the reason, that is why. If the two isothermal curves intersect or not. Let us go with PV indicator diagram. Suppose this is P is taken along y axis and volume V of gas is taken along x axis. Now for a certain temperature T1, the isothermal curve is like this. If this is A, B, the nature of curve we know is hyperbolic rectangular. Now again for another temperature T2, if the curve is like this, and this curve name is A1, B1, and now the AB and A1, B1 curve intersect each other at point say P. For a while we consider that they intersect. Now what happened there? Let us think that at the point P there is some fixed value of volume V1 and fixed value of pressure P1. That is for two different temperature, that is for two different temperature the value of the same value, as we take that for two curves there is only the value of volume is V1 and pressure is P1. So for two different temperature the same value of pressure and volume obtained which is practically impossible, because we know that pressure and temperature depends on pressure and volume depends on temperature. When there is change in temperature, the pressure and volume also changes. So, for the same value of pressure and temperature for two different temperatures cannot be possible in practical life. So, the two isothermal curves never intersect each other. अगर आपको अच्छा लगता है तो प्लीज़ मेरा बेल आइकन, जो चैनल का बेल आइकन है वो दबा दीजिएगा, सब सारे नोटिफिकेशन आप पाएंगे। और अगर आपको अच्छा लगता है तो सब्सक्राइब कीजिए, क्योंकि इन फ्यूचर डेज आई विल कम विथ ए लॉट ऑफ इंटरेस्टिंग टॉपिक, theory, numerical, and also the MCQ questions for NEET and JEE. That is, you will get complete package. My channel is not very old. It is 4 or 5 months while I started. So, if you cooperate me, then I will get more and more video for you. My aim is to understand the students who is afraid of physics. So, please support me. If it is possible to, next question is it possible to devise a heat engine which will create no thermal pollution? Next problem is it possible to devise a thermal engine, that is Carnot's engine, without थर्मल पॉल्यूशन? क्वेश्चन को समझ में आया क्या? क्या यह संभव है कि कोई भी थर्मल इंजन, अगर आपको थर्मल इंजन के बारे में नहीं पता है तो सेकेंड लॉ ऑफ थर्मोडायनामिक्स पढ़िए, अगर फिर भी आपको नहीं पता है तो मेरे कमेंट बॉक्स में लिखिए, मैं उसके ऊपर फर्स्ट लॉ ऑफ थर्मोडायनामिक्स और सेकेंड लॉ ऑफ थर्मोडायनामिक्स में मैं ज़रूर वीडियो बनाऊंगा विद डिटेल्स एक्सप्लेनेशन। सो इन दिस क्वेश्चन इट इज़ सेड दैट जे क्या यह मुमकिन है कि कोई भी थर्मल इंजन को ऐसे कंस्ट्रक्ट करना, बनाना जिसमें कोई भी तापीय पॉल्यूशन अर्थात थर्मल पॉल्यूशन ड्यू टू हीट इज ऑकर्ड? आंसर इज नो. It is in practical, it is not possible, because from second law of thermodynamics, from the second law of TD, that is thermodynamics, we can know that the work cannot be totally transferred to heat. Work cannot be totally transferred to heat, or heat cannot be totally transferred to work, or in reverse case we can say that heat cannot be totally transferred to work. Now, the amount of heat which does not convert it into work, where will it go? It go to the surroundings, and the surrounding is considered as sink. Which is sink? Sink has infinite thermal capacity, in which if we added some temperature, there will be no change in temperature. अगर आप सी या समुद्र के जो वाटर है उसमें अगर एक बाल्टी गर्म जल लेके उसमें पोर करते हैं, ढालते हैं, तो क्या उसका टेम्परेचर चेंज होगा? नहीं होगा. सो the sea, the water of sea is considered as sink. So, when the extra amount of heat that is does not convert it into work is go to the surroundings, so thermal pollution always occur. Only in ideal case thermal pollution will not occur. Which is the ideal case? That is, the source must be of infinite thermal capacity, the sink must be of infinite thermal capacity and the gas which is taken is ideal gas. Then only no thermal pollution will occur. And the fifth question is prove that show that the slope of isothermal curve is greater than slope of adiabatic curve. I guess इस क्वेश्चन का जो आंसर आप लोग किया होगा, बट इट इज़ वेरी इंपॉर्टेंट. देखिए व्हाट इज स्लोप. स्लोप क्या होता है? अगर ये पीवी इंडिकेटर डायग्राम है, ए बी volume and pressure is taken along x and y axis, then slope means अगर मैं यहाँ पर कोई टेंजेंट ड्रॉ करता हूँ तो उसका जो थीटा है दैट इज tan थीटा. tan थीटा मीन्स परपेंडिकुलर अपॉन बेस which is perpendicular change in pressure and change in volume, that is dP by dV. This gets the slope of the isothermal curve. Now if we evaluate dP dV for the two process, then we can get the value of slope. Let us do with that. हम इधर isothermal का करते हैं, उधर adiabatic. For isothermal process we get PV equal to constant. Now differentiate it, that is P fixed volume dV, V fixed change in pressure dP, and as K is constant its derivative is 0. So V dP is equal to minus P dV. Therefore slope, that is dP by dV isothermal iso equal to dP by dV equal to minus P by V. For adiabatic process we can get P V to the power gamma equal to constant. Now if we differentiate it, then let us take pressure P fixed, and this is gamma V to the power gamma minus 1 dV, nx to the power n minus 1 is the formula. Therefore V to the power gamma dP is equal to again 0 because of the K is constant. Now if we evaluate it, then V to the power gamma V to the power gamma is cancel, that is we can get P gamma dV plus V dP is equal to 0. Therefore V dP is equal to minus P gamma dV. That is dP by dV adiabatic is given by dP by dV equal to minus gamma P by V, that is gamma into minus P by V, which is nothing but the slope of isothermal. So slope of adiabatic is equal to gamma, slope of adiabatic equal to gamma into slope of isothermal. As gamma is a positive quantity, what is gamma? What is gamma? And gamma is equal to the ratio of molar specific heat at constant pressure and constant volume, Cp by Cv. We know this is always positive because there is no negative value of Cp and Cv. Gamma gives the estimations of the molecular of the atomic value, that is the for monoatomic or diatomic or triatomic molecule, the different value gamma signifies their number of atoms is constructed to make a single molecule, single molecule. So gamma equal to Cp by Cv, that is the adiabatic curve is greater than the isothermal curve, and how much greater? Gamma. So if we draw two curves in PV indicator diagram, then V and P, then obviously the adiabatic curves, if this is isothermal curve, this is isothermal curve, then the adiabatic curve is steeper, that is इसका जो स्लोप है वो ज़्यादा होगा, गामा greater than gamma. If this is AB and this is A dash B dash, then slope of A dash B dash is more than slope of AB, and how much? Gamma times. So this is the 5 important question in thermodynamics which you can be considered and for future exam ये आ भी सकते हैं. So अगर आपको मेरा लेक्चर अच्छा लगा तो प्लीज़ सब्सक्राइब कीजिए और नोटिफिकेशन को दबा दीजिए फॉर द फ्यूचर वेरी इंटरेस्टिंग लेक्चर. थैंक यू.